Differential equations for applications. We're going to solve the differential equations by separation of variables. A reminder of what differential equations are. They are equations that involve the derivative of a function and the function itself. The goal will be about solving them would be to find the function that makes the equation an identity. These are examples of different differential equations. This is the one we did in class last time. Notice that they involve the derivative of y with respect to time in this case, and y itself. We're going to solve dy dt equals k times y squared. Well, we start with this equation, and we need to separate the variables, so the dt must go on the other side. So we'll multiply both sides of the equation times dt. That leaves dy equals ky squared dt. The y goes with the y, so divide by y squared. And we get dy over y squared equals k times dt. Now that we have the differentials on each side, we integrate both sides. The integral of y to the negative 2, that's division by y squared, dy is the integral of k dt. Remember, k is just a constant. So the antiderivative of y to the negative 2 is y to the negative 1 divided by negative 1. And that equals, well, the antiderivative of k is kt plus a constant of integration. I'm going to take this to the next slide. Here it is. And we're solving for y. So first I'm going to rewrite y to the negative 1 as 1 over y. So we have negative 1 over y equals kt plus c. Get rid of the negative. 1 over y equals negative kt, the quantity kt plus c. And the reciprocal, y equals negative 1 over kt plus c. Sometimes you are given an initial condition. In this case, the initial condition will be y equals 1/4 when t is 0. So I take the equation, substitute 1/4 for y here, and t for 0. So we have that. And then solve for the constant of integration. And we get that c is negative 4. So I rewrite the equation, the function, as with c being negative 4. Let's see another one. dy dt equals n minus ky. So we need to separate the variables. We're going to move the dt on the other side and multiply this whole product. In order to move the y over here, I have to divide the whole difference, n minus ky. So dy over n minus ky equals dt. Then we integrate on both sides. Integral of dy over n minus ky equals the integral of dt. Now to get this integral, we're going to use substitution. If at any point you need to stop this to try to do it on your own, go ahead, stop it. You can watch it afterwards. Substitution. I'm going to use substitution for the denominator here. U equals n minus ky. So du equals negative ky. Substituting, we're going to get the integral on the left side is going to be 1 minus negative 1 over k times the integral of du over u. And the integral on the right side, nothing has changed, so just the integral of dt. The integral of du over u is the natural logarithm of the absolute value of u. So this becomes negative 1 over k, natural logarithm of n minus ky. This really should have been absolute value. My mistake. The integral of dt is t plus the constant of integration. Notice I put a subindex because we're going to change that constant. Okay, we need to solve for y. So first we get rid of negative 1 over k by multiplying times k. We get this, and on this side, negative kt times negative k times c sub 1. But negative k times c sub 1 is just another constant I'm going to call c sub 2. So this is what we got. Now, to get rid of the natural logarithm, we we've used the exponential function. We raise this to e to the this power. That's what we got here. A little algebraic manipulation, because the exponents are being added, is like the powers are being multiplied. But e to the c sub 2 is simply another constant. I'm going to call c. If I still had the absolute value, which I should, that simply becomes part of the other constant when we take it out. Again, we're solving for y. So subtract n. We get negative ky equals c e to the negative kt minus n. And then divide by minus k. I got it in red here. On the left side, it cancels. On the right side, this is the function that we get. Okay, if the initial condition is there was nothing at the beginning, y is 0 when t is 0, it's a matter of substituting. Instead of instead of t, 0, and instead of y, 0. This yields that c equals n. And we have the equation y equals n e to the negative kt minus n over negative k. That's the function. We get a common factor in n, and the negative k is a common outside. It's negative n over k e to the negative kt minus 1.